In the second part of this tutorial, we'll be going over how to fit a multinomial logistic regression model. So a multinomial logistic regression model is used when your response variable has more than two classes, right? So in the previous examples, we were looking at the situation when the response was binary. In this case, we'll be looking at an example where the response has more than two classes. So the data set is a data set from a survey in Indonesia regarding the use of contraceptives. And so the subjects were basically married women in Indonesia. So one thing to take note of, in a lot of the examples that we've done so far, we've always typed in header equals true, because if you look at the original data in the text file, the first row usually was the heading of the columns. In this example, there was no heading at all. So in this example, what you want to do is use header equals false, right, to tell R that the first row is not the header, that it's part of the data set. So I'm going to do that, and let's read it in. This is a pretty big data set, 1,473 people, with a bunch of different, I don't think you can see, right? And again, you notice these are not labeled. So we have to give the descriptive names over here. So basically, I'm giving you the descriptive names in the description of the in the PDF file, right? So we're just going to do that. That's going to append these names: age of the wife, education level of the wife, for each column, and then I'm going to attach this data set, right? So one of the variables that we are thinking of is using what we call the wife's religion, and it's binary. It's coded 1 for Islam and 0 for other religion. So if you type in wife rel, you might notice there's a bunch of zeros and ones, and when you see this, right away you want to think, right, I think R is probably treating this variable as quantitative. So like before, we can use the isNumeric function to see that, and yeah, we do see that R is treating this variable as quantitative, which we don't want to. So we're just going to convert this variable to categorical. So this now tells R, I want you to treat this variable as a categorical variable. And we can just confirm it by using the isNumeric and isFactor. Right now we see that R treats this variable, the wife's religion, as a categorical variable. The next thing to realize is the levels, right, is coded as 0 and 1. I tend to like to give descriptive names for each level. So 0 is for a wife who doesn't follow Islam, and 1 is for a wife who follows the Islamic religion. So we'll just put that into our data set. The response variable that we want to look at will be the contraceptive method, which is C method. And again, if you type that in, just to see how it's recorded, you see it's recorded as 1, 2, and 3. And if you look at the description of the data set, 1 is coded as the wife doesn't use any contraceptive methods. 2 is coded for a wife who uses long-term contraceptive methods, and 3 will be a wife who uses short-term contraceptive methods. So we want to do the same thing as before. We want to tell R to treat this variable as categorical, and I'm going to give descriptive names right, for no long-term and short-term contraceptive methods. So now we're ready to proceed. We're going to use this contraceptive method as the response variable. And we're going to use two quantitative variables, the number of children they have and the religion of the wife, right, to see whether those two predictors could potentially influence, right, the probability of what kind of contraceptive method the wife chooses. So the multinomial logistic regression model, the function for that is found in the nnet package. So be sure to install that. I already have that installed, so I'm just going to load the library. And the function is multinom, my response variable, and then my two predictors. And I'm going to use summary as usual to see the output of this multinomial regression. So one of the things I've mentioned before is sometimes R will provide you the test statistic and p-value. In this example, you notice that this function only gives us the estimated coefficients and the standard errors associated with each coefficient, as well as the residual deviance and the AIC. It doesn't give us the value of the test statistic or the p-value associated with each of these estimated coefficients. So in this case, we notice, right, that we have one row for long term and one row for short term. So this tells us that the reference class is for women who don't use contraceptives at all. right? So we don't know whether these coefficients are significant or not. So to do that, right, we need to calculate first the z-statistic. So the z-statistic is always the value of the coefficient divided by the standard error. So that's what I have over in this line of code, right, is to draw the coefficients and divide each coefficient by its corresponding standard error. And then I'm going to just produce the z-statistics for these over here, so we can kind of see what the z-statistics are. Right, so pretty big z-statistics, 5 and 3. So we kind of know already, right, if it's greater than 1.96, we probably will reject it. So this tells us that that the number of children is a significant predictor, right, for what kind of contraceptive method they use. And if you're comparing between long-term and women who use long-term contraceptives versus women who don't use contraceptives at all, it appears that religion, right, is a significant predictor. If you're comparing women who use short-term contraceptives versus no contraceptives at all, it looks like religion might be insignificant, right, because this looks like it's smaller than the critical value. To find the p-value, right, we just need to find the p-value associated with our z-statistics. We can use this code, right? It's we're going to find whether it's significant or not, so it's going to be a two-sided test, so that's why this is multiplied by 2. So this will give us the p-value associated with each of these, and right, these are all expected going to be significant. This one is 0.3, right, which is greater than alpha of 0.05. So the data seems to suggest children, the number of children you have, the woman seems to be a significant predictor on whether to have a significant impact on, right, whether they use long-term versus no contraceptives, or even short-term versus no contraceptives. Wife's religion does seem to be significant, right, if you're comparing between women who use long-term contraceptives versus those who don't. But for women who use short-term contraceptives and don't use contraceptives at all, it appears that the wife's religion doesn't have a significant impact on that decision. Okay, so this is just one thing, as I said, right, in R, very often there are all these different functions, and not all of them will produce the z-statistics or the p-value, so you have to calculate it on your own. So that's what we can do in the context of a multinomial logistic regression with this example.